This recording is protected by copyright. No part may be reproduced without the prior permission of the University of South Australia.
Okay. You've done SADPN with May. Did you do it with May or with Elena? When did you do it? Last study period or last year?
Last year.
I didn't teach systems analysis. I taught ISDP.
Yeah, project management and system analysis.
There was information systems professional practice. It was a 9-unit course which I taught. There was another 9-unit course called systems analysis, design and project management. Did you do that one? You done both? You've done both? Then you shouldn't be doing this.
Yeah, that's what I passed both. I got P1 in that and C in this.
Okay.
So I need to go.
You need to go to your program director and swap, because this is definitely should be doing this.
Yeah, that's what I was thinking about. So,
Grant, whoever your program director is, Grant Wigley, he's at North Lakes on the D building. I don't know your stuff. Write it down for you if you've got a phone or whatever, just write it on your phone.
When's the ebook going to be available? Because you said chapter 1 was meant to be read this week.
Yeah, but chapter 1's on the website.
Oh,
Or is it online chapter? Sorry, no. Online chapter's on the website. They're still developing it in the United States. I'm still waiting for the person to let you know, so the answer is I don't know. So you're holding out the ebook. It should have been out by week 1, but obviously I don't know. Sorry. Yeah, so walking that way.
yeah.
Go to the meeting group and go to the school office or send Grant an email. So can I come and see you? Because you need to change your programs. Okay? No worries. Okay. Did you do a head count, Daniel? Come on. Give or take. Give or take. All right. So, welcome everyone to week 3 of systems analysis. Can you hear me through the microphone? It's all good? Yep, can you let me know if you can't hear me, because the battery's on one bar for this as well. Okay, so today's lecture is basically going to provide you with, I guess, the foundations for what we are covering throughout the study period. So you'll have an overview of systems analysis, and we'll basically do a run through, as is done in the chapter of the textbook, a run through of a sample system and what the outputs are that need to be produced throughout the analysis of a particular system. Now this chapter is called an overview of systems analysis and design. Obviously design is not a component of this course. You'll be doing design probably this time next year. So although the chapter gives you an overview of the whole analysis and design process, I'll only be covering the analysis component today and throughout this course. Make sense? Okay, so what we'll be looking at is software development in the context of systems analysis and design. There are different types of life cycles that one needs to adhere to when doing systems development. And as IT professionals, as systems analysts, you should be familiar with what is known as the systems development life cycle. And there are different life cycles and different approaches that can be taken, but we'll be looking at one particular approach in this course. We'll also look at the concept of iterative development. Then we'll run through the case study scenario that's provided in the textbook, where we have an introduction to Ridgeline Mountain Outfitters, otherwise known as RMO. And we'll look at a scenario where we are developing RMO's trade show system and what the actual artefacts are that are produced as a result of analysing this particular system. So after completing this topic as a summary, hopefully you should be able to look at the purpose of systems analysis and design, why we even bother doing it when developing information systems. Why do we have a systems development life cycle, and what are the 6 core processes that are identified in this particular life cycle that we run through in this chapter and in this book. We look at how information system methodologies provide guidelines for providing or carrying out those 6 processes in the life cycle, and we'll also have a snapshot and a look at the characteristics of agile methodologies versus iterative system development. We'll then go into looking at the specific case study presented in the textbook for RMO and for their trade show system. And the examples we'll be looking at will actually run through the 6 core processes of the systems development life cycle and show how they are used in different iterations of the project life cycle. We'll look at the key documents used in planning a project, and we'll also look at key diagrams used in systems analysis and systems design. You're going to see some overlaps, as I've mentioned in this course, between systems analysis and some components of project management. Hence why I thought it was a really clever idea of me to come up with some colouring in the slides. Hence why I've coloured the planning a project a kind of yucky orangey colour, whatever colour that may be, because that's kind of to do with project management and the things that we'll be talking about in project management if you're doing project management with me. Systems analysis is what we're covering in this course. The components in green are related to systems design and or activities that are done after systems design. Right, so the yellowy parts are to do with the project management, the black parts are the analysis, the green parts are design and whatever happens after analysis. So the reading for today's lecture is chapter 1. So this chapter pretty much takes you through the entire process of developing a really small information system, just to give you a holistic view of how the textbook runs, how this course is going to be run. But only from our perspective, we're looking at the systems analysis component. And the rest of the textbook basically elaborates on those basic processes shown in chapter 1. So again, today's a holistic view, an overarching view, a simple example of how to carry out systems analysis for an IT project. Then the up and coming weeks will go into further detail to look at each of these processes, tools, techniques and artefacts that you need to come up with throughout each of the phases of the systems development life cycle and through the steps of systems analysis. So some definitions which I'm not going to go into in too much detail because, correct me if I'm wrong, we did cover some of these in last week's tutorial. Yes, no? We looked at the difference between a computer app and an information system. The key important thing to recognise with an information system is the system is not just about the technology that you have in front of you. We need to think about the components that make up an information system, whether it's the hardware, whether it's the software, whether it's the information that use the systems. But we need to be cognizant of the fact that an information system is actually doing something. It's collecting information, it's processing information, it's storing that information, but not only that, it's providing that information to someone or another system. Okay, so the information system does something with the information that it's getting. Again, recapping what we've sort of covered last week and in week 1, the distinction between systems analysis and systems design. In analysis, we look at the activities that determine or enable us to understand a specific problem and document and specify what an information system needs to accomplish. Whereas the design components, which again is the follow-on course, you look at the activities that enable a person to describe in detail and solve the system's needs. Okay, so how does the system operate? How does it solve the problem versus what is required for solving the problem? When we have a particular problem in software development, there are certain things that you need to consider. And I guess I've got some, for some reason, the number 7 appears again, but it wasn't intentional. We have 7 things to consider where we need to understand the need. We need to capture the vision of the project. We need to define a solution, communicate it, build the solution, confirm the solution, and launch the system. Again, this is all to do with software development, the whole process, not just the analysis component. It's important to give you an overarching view so you can see how systems analysis fits within the development process. Hence, we need to think about systems development life cycles. Again, you'll see the colour coming in to give you some distinction between what forms what part of what we do. So the systems development life cycle has 6 core processes. The first 2 processes, identify the problem or need and obtain approval, and plan and monitor the project, are to do with project management and your initiation stage and your starting up your project and your planning phases of project management. Again, not covering those in too much detail in this course, but we will be covering them to some extent because you can't really do the analysis unless you've done that pre-work in the beginning and established the problem and established the needs of the organisation and established a plan to carry out the project. So, although we're not covering them in detail, we will be touching on them. Core process number 3 is really where systems analysis kicks in. Discover and understand the details of the problem or the need. This is systems analysis. Core process number 4 is where systems design comes in. Design the system components that solve the problem. That's your systems design. That's what you'll be looking at in the next iteration of your studies, next year, next study period, whenever you're doing it. Not next study period, because it's not offered next study period. This time next year, hopefully. Phases 5 and 6, where we build, test and integrate the components and complete system tests and then deploy the solution, again, may form part of design, but generally come after design. Okay, so sometimes they're discussed as part of design, but traditionally 3 is analysis, 4 is design. 5 and 6 you normally do in your programming courses, okay, where you build, test and integrate the components. Okay? So you can see here I've got individual slides for each of the core processes, and I've identified some of the activities that you need to conduct within each of those core processes. I'm not going to go through each of those in a great amount of detail, but I've provided them for your benefit so you can actually see the kinds of things that actually occur and happen within each of those core within each of those core processes. So you can see, as an example, core process number 1, it would help if I shine it at the right thing. We identify the problem and obtain approval. So we need to think about what the problem is. We need to you need to have some approval factors. You need to perform a risk and feasibility analysis, and then you need to review it with the client and obtain approval. Then you move on to core process 2, where you plan and monitor, which is again your project management components. Then we do our analysis activities, and these are the things that we're going to be covering throughout the up and coming weeks, where we need to gather detailed information. We need to define the requirements of the course. We need to prioritise requirements. We need to look at developing user interface designs and dialogues. And most importantly, you need to evaluate those requirements with your users. Why do you need to evaluate those requirements with your users? Why do you think you need to evaluate those requirements with your users? Oh, we had a couple of make sures to start off with. Okay, well, make sure it's what they want. If you haven't specified the requirements properly, is that what you were going to say? Pretty much, close enough. If you haven't specified the requirements correctly, your IT project is destined for success or failure. Is your project destined for success or failure? Either or. I'm sure you've been discussing it quite. Success? No. You had a 50-50 chance. If you don't evaluate those requirements with users, you need to be wary of the risks that can occur because you haven't got the right requirements. Core process 4, design activities. Then we've got core processes 5 and 6, which again are highlighted in the book, but we're not going to be covering them in this course. So, by now, I'll be deeply concerned if you don't know what a project is, because I've said it like a number of times in this course, and for those of you that were here, that have been here for the last 3 weeks for both courses. IT projects, there are lots of them. Organisations need to be wary of the projects that they have. Organisations need to be wary of how they use their IT systems. How can they better use their IT systems? How can they remain viable in today's ever-changing marketplace? So we need to think about projects from an information systems perspective and how we can ensure that we develop information systems that are going to suit the needs of our target audience. So we then follow some sort of system development process. We can use unified programming, we can use extreme program, we can use Scrum. Most processes and methodologies now use agile and iterative development because we can iterate the way we are doing things. We can have some, I guess, short-term successes, and you can plan what you are doing and you can monitor what you're doing rather than doing it all as one big, large project that might be destined for failure at the end, or might be over time, over budget, or under-resourced, etc. So iterative and incremental development are, I guess, analogous to rapid application design, which is what used to be called years ago, where you are working together to come up with products that are clearly defined and can be used and tested throughout the implementation of a project. So iterative development, again we have agile development, we have iterative development. They are basically approaches of how you develop systems, and with iterative and agile we look at flexible systems, we want fast design, we want systems that can be responsive to change because we know how quickly things are changing in IT, and we need to think about completing a project as part of a sequence of mini projects and then repeat those and refine those until we complete the objectives of the actual project. So this is basically a snapshot of those core processes represented in the iterative and agile systems development lifecycle. So we have 6 core processes that I've already mentioned. Identify the problem and obtain the approval, plan and monitor the project, discover and understand details, design system components, build, test and integrate system components and complete the system tests and deploy the solution. Which one of those core processes is systems analysis? I'm not going to ask you. Sorry? Nope. What's process 1 part of? Project management. What else is part of project management? Process 1 and 2 are part of project management. Process 3 is systems analysis. Process 4 is systems design. 5 and 6 can be part or post-design. Okay, so process 3 is systems analysis. Now you can see with those iterations, as you carry out a project iteratively, the peaks and the troughs. So initially when you start out the project, you're going to spend a lot of time in planning your project. Okay? But having said that, you're also going to do a little bit of these other components where you can, except for obviously deploying the solution in your first phase, or your first iteration. Then you think about continuing that, but not so much identifying the problem, but a bit more about planning and monitoring. But then you start kicking in with your analysis. And you can do a little bit of design, bit of building and testing at the same time. Don't really need to think about identifying the problem anymore. You're always planning and you're always monitoring your project. So you can see this occurs throughout the phase of a project in some form or another, but it tapers down as you get towards the end. Iterations 2 and 3 and 4 are pretty much systems analysis. By the time you've hit the end, you don't really want to be analysing anymore. That should be done. Iterations 2, 3 and 4, heavily doing the design, and also some in 5, but you don't want to be designing at the end. Iterations, all of them actually, you're doing some sort of building, testing, I like that, testing and integrating, because we're doing iterative and agile systems development. So you want to be doing some of these things throughout the way, but predominantly in iterations 3, 4, 5 and 6. In the beginning, you don't really want to be completing system tests and deploying the solution because you're still identifying the problem and carrying out your analysis and some design. So you want to start thinking about doing that for some of the components partway through your life cycle and partway through your iterations, and then really ramp it up at the end. Okay, so you can see how we've got our core processes. You carry them out via some iterations, and you can see by that picture what happens and when things are likely to happen throughout a project and through its life cycle of developing a system. Who has watched the video on the course website? And you can't say you didn't know it was there because I put it up last week and I sent you all an email the day I put it up. Did you all get that email, by the way? Are you sure? Did anyone get an email from Learn Online, from the forum, from me last week, because I got it, saying that the materials are on the course website? Because if you're not, then I need to raise it with Learn Online. It wouldn't have probably come from me, probably would have come from Learn Online. If I can get you to just check to see if any of you got it. You did get it? Oh, you're checking now. Okay. I'm sure I sent them out last week or early this... Yeah, would have been last week sometime. And I also placed it on the news forum, on the news discussion forum. Anyway, the video basically pretty much talks about that diagram that I've just gone through. So now we'll look at the Ridgeline Mountain Outfitters case study and have a look at what that talks about as an example of running through systems analysis. So RMO, I guess, is a large retail company. You can see on the website that they have a winter catalogue. They have multiple locations and they provide lots of cool stuff. If you're interested in outdoor stuff, if you're interested in skiing and mountain biking and water sports and hiking and camping and mountain climbing and mountain biking. Oh, that sounds scary. Mountain biking. Is anyone game for mountain biking? I wouldn't be. Anyway, that's probably why they're called Rocky Mountain and West. No, they're in Rocky Mountain and they're in the Western States. And what they've done is they've started mail order and phone order facilities. They've added some retail stores. I'm going to split you guys up next week. You watch. And they've added an extensive e-business component to the functionalities and the course website. So here you can see their winter catalogue, which is on their website. And you can see their website, which allows you to shop for gear, shop for clothing. It has a wish list, store locator, my account and my orders. Now, these things don't happen by themselves. There's got to be some sort of information system to support what's going on within this particular organisation. So they have a clearly defined organisational structure. They have, there are 3 RMO system development projects that are actually discussed in the text. And we'll be looking at those throughout the course. And there is a well-defined application architecture for those 3 RMO projects. So you can see how each of those 3, I guess, RMO projects or those systems communicate with each other or how they are integrated with each other. I believe you will also obtain this information. If you haven't read the textbook, you will obtain this information by preparing for this week's tutorial. No, next week's tutorial, because the tutorial next week is based on what we're covering today. So there'll be a bit more information that you can obtain by watching a video, but also it's outlined in the course textbook. So let's have a look at developing RMO's trade show system. So this system is the actual sample project for the chapter. It's a small information system that's been developed as part of their entire system, and it's being added to a larger supply chain management system. So there are some systems that are talking to each other and have been integrated with each other to resolve the issues and the problems that RMO are currently experiencing. The RMO trade show system demonstrates one iteration of a small project. It goes through all of those 6 core processes. Okay, I'm moving my hands up and down because I'm referring to the slide, the diagram a couple of slides ago, which had the 6 core processes going down, and then we had some iterations going across. In this textbook, we've got the 6 core processes and we've got those 6 iterations. Each of those iterations in this chapter, for the purposes of this chapter and the text, is represented as 1 day. So we're going to go through, well, not all of them, but I've highlighted them because some are to do with design and etc. But the chapter actually goes through all the 6 core processes of the SDLC. And as I said, the plan for this chapter is to complete the iteration in 6 days. So what's the problem? The problem that RMO has, and they want to achieve with their trade show system, is that purchasing agents actually go to fabric trade shows around the world to order new products from suppliers. What they need is an information system to collect and track information about the suppliers and about new products while at these trade shows. The trade show project that has been proposed consists of 2 subsystems. One of those is a supplier information subsystem. The other is a product information subsystem. I'm consistent with my colouring. Okay, so initial activities pre-project are part of what? What are the initial activities and pre-project part of? Are they part of analysis? Are they part of design? Are they part of project management? Well done, Navina. Project management. Okay, hence the orange colouring. So these are what we do with project management. We identify the problem, we do a preliminary investigation, we conduct a system vision document. We then obtain approval to commence the project. You meet with key stakeholders, including executive management, you reach decisions, you approve and plan the project. Now, I said to you that this is part of project management, but some of these things we need to do as part of systems analysis, because before you do any of the diagrams that I want you to do, you need to think about why you're doing this project. So coming up with a preliminary investigation or a system vision document, why we're actually doing this project. So some objectives and goals that you want to reach. So yes, there is some alignment between the two, but some of them you need to do in both. So as a snapshot, and again this is presented in the textbook, this is what a system vision document looks like. And it has 3 sections. A problem description is the first section, which tells us what they're trying to achieve as a result of this new information system or these new information systems or subsystems. What is the actual new system going to do? How are you going to make sure that it's doing the right thing? So this is where we're specifying what it's supposed to do. And what are the business benefits? Why are we even doing this particular project? Why are we creating this information system? So in one document, by addressing those 3 things, you can basically specify what's going on and the reasoning behind what's leading you to do this particular project or task. So that's pre-project, that's initiation. We haven't even hit day 1 yet. We now hit day 1, which is core process 2. Core process 2, still part of project management, where we need to plan the project. What are we doing? We look at the major components, and in this particular case or instance, it has been decided there are 2 small subsystems, supplier and product information subsystem. So we've got 2 small subsystems forming one larger system. So we can break this down into component parts. We can break the system down into 2 subsystems. So we need to think about defining the iterations and assigning a function to an iteration. In this instance, a decision has been made to do the supplier subsystem first. And this is what we'll be looking at as part of the chapter. Plan one iteration as it is a small and straightforward one. Okay, so we're not doing it forever and a day. What you need to do is determine team members and responsibilities. So a work breakdown structure, again part of project management, but also part of systems analysis, because if you can't do it and if you don't define it, you're not going to know what's going to happen and when it's going to happen. What this work breakdown structure actually does, it gives you a holistic view or a whole development life cycle view, and it shows you what's happening during core processes 3, 4, 5 and 6. Processes 3, 4, 5 and 6, analysis, design, post-design. So we're specifying here what's going on in analysis, what's going on in design, what's going on when we build, and what's going on when we do the system tests. We are also specifying for each of those processes or parts of the system development life cycle who's doing, well, not who's doing what needs to occur, and how long these tasks should be taking. Again, it's a representative sample, it's a small project, but it gives you an indication of what you need to do to set yourself up before you actually do your systems analysis. Without this planning and without this document, you cannot proceed because you don't have this information as a basis, as a guideline. The work sequence draft for iteration also elaborates on this particular work breakdown structure. So what it actually gives you is a little bit more information in terms of the sequence of what needs to be conducted, if you can do anything at the same time. Okay, so here we can see that day 2 is for 12 hours, which is made up of 4, 7, 10, 12. That's day 2. It gives you a sequence of how we carry those tasks out for day 2, being we meet with the purchasing manager, we meet with the purchasing agents. Once we've done those 2, we can then define the use cases and define information requirements. Once you've done those, then you need to develop workflows. But you can't develop the screens until you develop the workflows. So it gives you a flow of what work needs to be done. So you can visually represent, A, the tasks in your work breakdown structure and how they are to be done. And then you can produce a work sequence draft to show you the sequence of the work that needs to be carried out. Day 2 activities. Core process 3. What's core process 3, everyone? Systems analysis. Okay, this is where we do the systems analysis. This is the whole course. This is it. In 3 dot points. Yay, we're done. Let's go. Okay. I wish it was that easy. So, core process 3 is where we do our systems analysis activities. We need to do our preliminary fact finding to figure out what the requirements of the system is. We need to develop a preliminary list of use cases and a use case diagram. Whoa, what's a use case? What's a use case diagram? I know, and you're going to find out. We need to develop a preliminary list of classes and a class diagram. What are classes and what's a class diagram? You're all going to know soon enough. So, here's an example. And again, this is just a simple example to demonstrate how we go through the process. You are going to be going through these throughout the up and coming weeks. And you're going to be developing these for sample scenarios in your tutorials, in your assignments, in your exam. Yay. So, identify use cases. Pretty much a use case looks at what are the functions that need to be done in this particular system. In this case, we're looking at the supplier system as well as the product system. So, for the supplier system, these are the things that we want the supplier system to do. We want to be able to look up a supplier. We want to be able to enter and update supplier information. We want to be able to look up a contact. We want to be able to enter and update contact information. For the product subsystem, we want to do these 3 things. And it gives you a bit of a description of what those use cases are meant to do. So when we look up product information, we want to be able to use the description or supplier name to look up a product information. For looking up a supplier, we want to use the supplier name to find supplier information and contacts. So a brief description of what that use case needs to do. Once you've identified your use cases for both systems or any particular system, you need to identify the object classes. We talked about any of this in database fundamentals yet? Is anyone here not doing database fundamentals? Yay, you're doing it. Okay, so you need to think about how you're going to store the information. Simple as that, really, in principle. We're going to have 4 classes: supplier, contact, product, product picture. In each of those classes, you need to think about what information you're going to hold and how you're going to store that information. So you need to think about, for the supplier class, what are the actual fields of information that we're going to store, or do we need to store for a supplier? We want the name, address, description and comments, etc., etc. So for both subsystems, we've defined 4 particular classes and the attributes that need to be stored for each of those classes. If you haven't done any of these, you will, either through me or through previous courses or through other courses. But you need to come up with a class diagram. Okay, so I expect you, because a lot of you nodded your heads, to all be experts at creating class diagrams. So this basically represents how all the tables or the classes fit together, how they are related to each other, what the, I guess, connection is between those classes, and what the relationship is between those classes, whether it's a one-to-one or a one-to-many relationship between those classes. In day 3, we're still in core process number 3, where we are discovering and understanding the details. This is where you do some in-depth fact-finding to understand the requirements, and you need to understand and document the detailed workflow of each use case. So a few more diagrams that need to be conducted as part of your analysis. In the book, day 3 also moves on to core process number 4. Again, colour convention, green, that's systems design. Not covering it in this course. So, we are moving on and continuing with core process number 3, where we discover and understand details. So, for the supplier information subsystem, we have 4 use cases. Look up supplier, enter update supplier information, look up contact information, and enter update contact information. One thing that you need to create is something called a use case diagram. Has anyone seen a use case diagram before? One of you has. This basically outlines the functions, I guess, of the system, and it gives you a representation of who is responsible or who is interacting with those functions or use cases in that system. And this is a snapshot of a use case diagram for the supplier information subsystem. Those 4 use cases are those 4 ovals here. The manager uses lookup supplier and lookup contact. The purchasing agent uses all 4 of those use cases, or interacts with all 4 of those use cases. So for a particular system, you come up with one use case diagram, but it gets better, because you need to do a little bit more after that once you've identified and come up with a pretty picture. And by the way, you need to, as a systems analyst, come up with the appropriate tools to draw these pretty diagrams. What tools are you going to use? There are lots out there, and that might be a task that I'll give you to do, or I might tell you what tool to use. There are a few things out there, but, you know, that's your role as systems analysts. How am I going to portray this system visually to the customer to ensure that the functions I'm providing are what the system is actually supposed to do? You know, so it's all well and good to come up with a list, but you need to visually represent that list in the form of a use case diagram and demonstrate and show in that use case diagram who is interacting with those components and those use cases. And you need to use the tools to represent it visually. Not only do you need to come up with a use case diagram, you need to explain to your user and find out from your user, what does lookup supplier mean? What are we supposed to do in the lookup supplier use case. What's the flow of work that carries out or is conducted when we look up a supplier? Well, you can see that with something called an activity diagram, which represents workflow. For the lookup supplier use case, which is lookup supplier, we identify the work that goes on from the purchasing agent's perspective. And for a purchasing agent, you demonstrate how they do their work when they look up a supplier. They enter a supplier name into the system. The system returns supplier information. If it's found, you continue. If it's not found, you must enter another supplier name. If you find it, you view the supplier and the contact names. Then you can look up the contact and select the contact name, retrieve the contact information, view contact information, end. If you're happy with what you've got here, you're done and you end. So you're really being prescriptive about how this system is flowing and what work is actually carried out. What's the point? Can't we just leave it at that? Why can't we just leave it at that? Too vague. Too vague from whose perspective? Sorry? The people that are going to have to implement it. That's exactly right. But not only from their perspective, from your perspective as a systems analyst, what you think might goes on in look up a supplier might be completely different to what the user expects to happen when they look up a supplier. So it's critical to take it to the next step and identify the workflow in terms of what goes on when we look up a supplier. And that's represented with an activity diagram. You need to do one of these for each use case. Okay? So the use case diagram is for the whole system. The activity diagram is for each use case. Oh, but wait, there's more. Day 4 activities is design system components. Day 5 activities is still 4 and 5. And day 6. So, as a really basic example and a simple snapshot, you can see the systems development life cycle and how it fits in together. So, again, a holistic view of where we're headed with this book and with this course and with the following weeks. Part 1 is an introduction to systems development. Last week we covered online chapter A, the role of the systems analyst and the importance of the role of a systems analyst. Chapter 1 has given you a small project overview emphasising analysis and design and iterative development.